let's take a look at the first couple of questions here in lesson 5 on functions as rules and tables. So it says identify the domain and range of the following functions where Dustin charges $10 per hour for mowing lawns. All right, domain are your possible x values. So those would be the amount of lawns that he mows. And he can go from 0 all the way up to as many as he wants. So I would say that the domain for number 1 is x is going to be greater than or equal to 0 because he can mow 0 lawns or he can mow 1,000 lawns or 57 lawns or as many lawns as he wants. Now negative numbers doesn't make sense there for the domain because he can't mow a negative amount of lawns. Now for the range, what's the possible range he can have? So those are your y values, and that would be the money that he makes. So again, if he doesn't mow any lawns, his value is going to be 0, right? But if he mows 1 lawn, then he gets $10. And it keeps going up from there. So we would say that the range for number 1 is y is greater than or equal to 0. For number 2, Maria charges $25 per hour for tutoring math with a minimum charge of $15. So x is the amount of hours that she can have. And I would say for the domain here, for our x values, she can have 0 hours, right? Or she can have more than that, as many hours as she wants. Now, it doesn't say within a day, so we're not going to limit it at 24 hours or anything like that. Because we don't know how long our span is going for. Is it going for a week? Is it going for 2 weeks? Is it going for a year? So that's why we're going to leave it at greater than or equal to 0. Our range, with a minimum charge of $15. So even if I'm still going to say 0 because y is greater than or equal to 0. We could maybe dispute that and say y is greater than or equal to 15, but I'm going to say 0 because if she doesn't tutor anybody, she can't even make a minimum charge, right? She would still get 0, so I think 0, 0 would be our first starting point. From there, we could look at if it were 1 hour of tutoring, we'd have the $25 plus the 15 for the minimum charge. So I guess there can be some dispute with the y is greater than or equal to 15, but I'm going to leave it as y is greater than or equal to 0, because if she doesn't tutor anybody, she's not making any money. For number 3, we can go ahead and we can look at the graph if we wanted to. So let me see if I can get a graphing calculator up in a window here. So f of x equals 15x minus 12. So if I were to just do 15x minus 12 here, we see that graph there. There is no constraints for what my x values can be, and there is no bound on what my y values can be. So here we would say the domain is all reals, so all real numbers, and the range is the same, all reals. So we do have a linear function there, so the domain and range are all reals. For number 4, let's go ahead and let's change this function to 2x squared plus 5. And I'm going to have to zoom out a little bit because it is way up here. We notice that our x values are any number, so we're going to leave our x as all reals for our domain. But our range changes. Our range is y is greater than or equal to 5. Because notice right here is at 5, right? And that's a little bit off. I'm a little bit lower than what my vertex is showing there. We only get y values of 5 or greater. So that's why we're having the range be y is greater than or equal to 5. For number 5, let's go ahead and do 1 divided by x. Well, when we see that, we get kind of split. I'm going to see if I can get this point taken off. Here, possibly not, maybe not. Oh well. All right, 1 over x, so we look like the x values here for the domain can actually be any number as long as it's not x equaling 0. So x cannot equal 0 for our domain, but it can equal any other number. If we were to choose -1, we get a y value. If I were to choose +5, I get a corresponding y value. But I do not get a corresponding y value if I choose x to be 0, because there's no point on either of those graphs there when x is 0. For our range, this is a little bit more tricky. I would say the exact same thing for our range. We have any y value except y can equal 0 as well. So as long as y is not 0, we will have a valid range. Let's go ahead and take a look at number 6, the square root. So I'm going to do SQRT because that is the abbreviation for a square root. The square root there for the domain is x is greater than or equal to 0 because we can take the square root of 0. It's just 0. And our range, again, is y is greater than or equal to 0 because we have any y value that is larger than or equal to 0. All right, for number 2, what is the range of the function when the domain is -2, -1, 0, 1, 2? Well, here we can do this with a calculator or without. We're just going to use simple substitution. So I'm going to make almost like a chart here. So x, y, when my domain are my x values, right? So when I substitute them in, let's see what we get for y. -2 squared is 4. 4 minus 5 is -1. -1 squared is 1. 1 minus 5 is -4. I get 0 minus 5. 1 minus 5 and 2 squared, so 4 minus 5. So it looks like my range for number 2 is -5, -4, and -1. We only get those 3 values there. Let's go ahead and I'm going to just jump down a little bit here. What is the range of the function when the domain this time is -2.5, -1.5, and 5. So I'm going to use my calculator, and hopefully you are going to do the same. So let's substitute in a -2.5 minus 3/4 in this first one. And when I do that, I get -5.75. I'm going to go ahead and substitute in a -1.5 now. And when I do that, I get a -3.75. And when I substitute in a +5, I get a 9.25. So my range are these 3 y values right here for number 3. For number 4, let's take a look here. What is the domain? So this time we're looking for the x values when we know the y values are 9, 12, and 15. So this time we're going to work backwards a little bit, right? We're going to go ahead and substitute 9 in for y and solve for x. So dividing each side by 3 gives me 3. 12. So 3 times what is 12? So 3 times 4. And then you can probably guess it. We would get 5 there for the last one. So the domain we're looking for here, number 4, is 3, 4, 5. And I'll see if I can squeeze number 5 in here as well. What is the range of the function when the domain is 9, 12, and 15? So now x values are 9, 12, and 15. So we're just going back to substitution again at number 5. So 3 times 9 is 27. 3 times 12 is 36. And 3 times 15 is 45. So here is the range when our domain is the 9, 12, and 15.